do this. This will probably be actually lesson 12 because lesson 11, I think I posted something else in there. I'll fix that. Today we're going to talk about combustion reactions when you're given the reactants. Okay? And we need to translate word equations to balanced chemical equations and vice versa. So here we go. Combustion reactions, of course, we talk about most of the time. They're going to be molecular compounds. They're going to be molecular compounds, and they're going to be very flammable. Okay? So a hydrocarbon combustion. In science here, we only do two atoms that we need to really worry about, and they're called hydrocarbons. Hydrogens and carbons are the only two that we really need to worry about here. So some examples include methane gas, which is CH4, propane that you would use to on your barbecue, for example, which would be C3H8, would be an example of that. Okay, and some other ones are listed there for you. I didn't put that in the notes; it's not a big deal. Okay, so complete combustion occurs when a hydrocarbon, so carbons and hydrogens. Okay, so when hydrogens and carbons react with oxygen, so you need oxygen to burn things. Okay, if you don't have oxygen, we don't have combustion. We don't have burning. Okay, so reacts with oxygen. So this part right here, okay, are your reactants. That CH4, C2H6 plus oxygen reactants. Okay, they produce always carbon dioxide and water. And those are your products, always. Okay? So, and unfortunately my example here has this little funny thing here. My thing doesn't transfer very well. So, for example, methane, CH4 plus O2 gives me carbon dioxide and water gas. Now, the products are a gas because it's extremely combustion. Endothermic or exothermic? You guys should know those terms, yes? Endo or exothermic? Exothermic. Gives off lots of heat. So those gases that we get are, that water and that carbon dioxide are in gas form. Okay? All right? If you had complete combustion here, basically they give you all, there's some examples here for you. We're going to skip that for now, and so on and so on. Okay? If you don't have complete combustion, what you get is carbon monoxide, CO. CO, of course, is very dangerous, yes? Carbon monoxide. It affects your central nervous system, basically, and that's what this slide here basically tells you. It's the most toxic produced by combustion, and basically it can kill you, right? So you should have, hopefully, and hopefully you do. If you don't, you should maybe talk to somebody about that. You should have carbon monoxide detectors in your house, yes? They make that really loud screaming, if you've never heard it before. If you have an RV trailer or a camper or whatever, you should have some in there too. That's when the fuel doesn't get burned completely, and instead of getting carbon dioxide, you get carbon monoxide, okay? And it goes through different stages, guys. You can have mild poisoning, which is basically they'll tell you the percentages, a moderate and severe, okay? Basically, the symptoms are, and we took this in the WHMIS, by the way, headaches, nausea, dizziness, breathlessness, you collapse, and then you basically lose consciousness eventually. Okay, yep. It's very, very dangerous, and it can happen in furnaces, like in your house and stuff like that too. So you should have a carbon monoxide detector, okay? It's not very common anymore, so it's not like, you know, I wouldn't freak out too much kind of thing, you know, but it still does happen occasionally, okay? So we're going to write out some things here, guys. So let's do these examples here real quick. Here we go. Write a balanced chemical equation for the complete combustion of propane, C3H8. C3H8. So I'd say, okay, word equation, I would say, we're going to call it propane, guys. Now, you don't have to know that. That's okay. Don't worry about that. But I'd say propane plus oxygen gives you, okay, once again, always plus oxygen, gives you carbon dioxide, and water. Okay? Always. Carbon dioxide and water. Carbon. The balanced chemical equation would look like this. So I'm going to ask you to write out, and I'll tell you that propane is C3H8. So you're going to write out propane. Propane actually turns out to be a gas, plus oxygen, which is a gas. And you will get carbon dioxide, gas, excuse me, and water, gas. Okay? That would be a chemical equation for the combustion of propane. C3H8, always plus oxygen. In fact, we call this the fuel. That's a fuel. Could be gasoline, okay? Could be wood. It could be whatever, okay? That's the fuel plus oxygen. Always gives you carbon dioxide and water. So you kind of have to memorize that part of it. Balancing. We need to balance. So look, 3 carbons, yes? Okay. 8 hydrogens, 4 times 2, 8 hydrogens, yes? Okay, 4 times 2, 8 hydrogens. Add up the oxygens. How many oxygens do I have here? 3 times 2 is 6, and 4 more, yes? So 6 and 4 is a total of 10 on that side. I would need 5 times 2, 10 oxygens. That would be balanced chemical equation for the combustion of, in this case, called propane. Or you could actually, guys, we could also call it tricarbon, yes? Tricarbon octahydride, yes? So we should be able to also write the formula for that. That's naming molecular compounds. That's what this is, tricarbon octahydride. Okay? Let's look at another example. Hexane, C6H14. Write out the balanced chemical equation. So here we go. They tell me that that one's a liquid. Okay, so I'll put an L there. Plus oxygen, always plus oxygen. Combustion plus oxygen. The products, of course, are always carbon, carbon dioxide, CO2, and H2O. Both of those will be a gas, always. Okay? Now, this one, same thing. Okay, are we good so far? Yes? Fuel. In this case, it's called hexane. Fuel plus oxygen. Look, if you're burning your car, if you put gasoline in your car, yes, you fill it up at the pump, does it not need oxygen to burn it? Yes? That's why you have an air filter, to clean the air that comes in. So it's clean air that you're burning. And what do you get out the exhaust pipe? Carbon dioxide and water gas. Okay, that's the steam you see in the wintertime. Smoke, yes? Unless your car is burning oil, that's a different kind of combustion. If you ever pull up to the pump and somebody says to you, "Can I check your gas and fill your oil?" you have a problem. Think about it. Can I check your gas and fill your oil? Yes, exactly. So if your car is burning lots of blue smoke, that's bad. That's oil. We want the opposite. Okay. All right, you guys. Period 4. 6 carbons. Here we go. 6 carbons. Yes? 14 hydrogens. 14. Well, that means I got to put a 7 there, yes? 7 times 2 is 14. Yes? Now, we're going to add up oxygens. 12. 6 times 2 is 12. And 7 more is a total of 19. Oh, I think we've already done this one, haven't we? 19. Those come in pairs. So I guess I'm in a little bit of trouble now, aren't I? Because 19's not even, right? So what's half of 19? 9.5. And I would put that in there, guys. You know, don't be shy. Put it in there. Is it balanced? Technically, yes. Can we leave it like that? No. So we're going to go back and double everything. Okay? Now it's easy for me because I have an eraser, but I'd put a 2 here. Okay? I'd put 19 here. Make sure you double every number, guys. 12. And 14. Okay? And that should be balanced. That's 38 oxygens. Yes? This is 24 right here. 12 times 2 is 24. And 14 more. 38. Okay? Trust me, it is. Okay? Combustion reactions. Okay, they either work out really nicely or they're not going to work out particularly well. Okay, and then you're going to have to go back and double stuff. All right, one more example. You guys do this one. C2H6. I'm just going to write this down. Yes. Okay, write out a chemical equation, balance it for me. Go, quickly. Plus oxygen, right? Always gives you carbon dioxide and water. Yes? You need to know that. Then, once at least you have that, guys, then it's just a matter of balancing chemical equations, right? Making sure you got the same number on both sides. 2 carbons, 2 carbons, 2 carbons, 2 carbons. Okay? 6 hydrogens. 6 hydrogens. So 3 times 2 is 6 hydrogens. Yes? Now, we're going to run into the same issue here. 4 oxygens and 3 more is 7 oxygens. Yes? 7. And these only come in 2s though, so what's a half of 7? 3.5. Is that balanced? Technically, is it balanced? Do I have the same number on both sides? Yes. Can I leave it like that? No. So let's go back and double everything. Yes. 2, 7, 4, and I had a 3 there before. I'm going to put a 6 there. Good? Is everything balanced now? You know, if the first one's balanced, guys, and you double everything, it should be fine. 4 carbons, 4 carbons. 12 hydrogens, 12 hydrogens. 14, 8 and 6 is 14. Good. Okay? And that's chemical, or that's combustion reactions. Always the same thing. Okay? Carbon, hydrogen, right? There'll be some kind of combination of those. Plus oxygen, carbon dioxide, water are your products. Okay, you got to start with that. Write it down and go from there. You guys got your questions in the homework on Google Classroom there.